Hello, everyone. In this lesson, we are starting Unit 4. Unit 4 is our unit on polynomial functions. We just finished a unit where we talked about polynomials. So we talked about adding and subtracting, multiplying and dividing, and now we're moving into polynomial functions where we solve polynomial equations and we graph polynomials. So in this lesson, what we are focusing on is solving polynomial equations. It involves factoring. So we spent a lot of time on factoring at the beginning of the year, and part of the reason why we did that is because we are going to use factoring quite a bit this year, and one of the places that we're going to use that is in this lesson. The next lesson I think that we will do on our next class day, depending on how long this video takes for us to get through. So with that being said, we are on page 46 in our notebook. We are on page 46. We're on the solving polynomials equations. Solving polynomial equations. When we are solving polynomial equations, you'll hear this referred to in a few different ways. So it's also called finding the zeros and finding the roots. Write that down, because you'll see that and you'll hear that. Solving polynomial equations is also called finding the zeros of the function or finding the roots of the function. So the first thing that we do is we're going to list the steps for solving polynomial equations. So step number 1 is the function must equal 0. And that's part of why we call this finding the zeros. If we want to find the zeros, then our function has to equal 0. So we want to make sure that f of x equals 0. The next thing we check for is a GCF. Factor out a GCF if possible. Then we want to factor completely. Factoring completely means you want to factor it as far as it'll go. So if you have a polynomial that is x to the 4th, you are not done until you have 4 factors. Then lastly, you set each factor to 0, then solve. So once you get to this last piece, that piece is the easiest. So we want things to be equal to 0 because solving equations is also called finding the zeros. And we're going to have to factor in most cases to do this. Our first problem, number 1, is an example of the first step. We have f of x equals x squared plus 6x plus 5. We need that to equal 0. So we're just going to rewrite this as x squared plus 6x plus 5 equals 0. The next step says factor out a GCF. Well, I don't have a GCF because there's not a number on the front and there is not a letter on the end. So I do not have a GCF. Next step, factor completely. This is a trinomial, so this is the one where we list all of the factors. Well, the only factors are 1 and 5. This plus sign right here tells me that I should be adding these factors. Those add to 6, and that's exactly what we wanted. We wanted a positive 6. So our factors are x plus 1 times x plus 5, and that still all equals 0. So my two factors are here, so I put them in their own binomial. Then we're at our last step. Set each factor equal to 0 and solve. So I'm going to say x plus 1 equals 0, comma, x plus 5 equals 0. Well, to solve this left-hand equation, all I need to do is subtract 1. If I want to get rid of a plus 1, I subtract 1. So my first 0, or my first solution, is x minus 1. My second, not x minus 1, I apologize, x equals negative 1. My second solution, I subtract 5 from both sides, and I get x is equal to negative 5. So I have two solutions here. X equals negative 1, x equals negative 5. Those are also called zeros or roots. The last thing that I want to highlight before I go on to the next problem is that your exponent tells you how many factors you should have. So that 2 tells me that I should have 2 boxes down here with zeros in them. So that means for our next problem, by the time we're done, I should have 3 boxes with zeros in them, with solutions in them. We follow our steps as we did before. Step number 1, my function needs to equal 0. Luckily, mine does. It already equals 0. So now we go to the next one, factor out a GCF if possible. Well, there's no number on the front, but there is this letter on the end. So that means that I can take an x from each term in this trinomial. So I'm going to factor out an x. I'm going to leave a little bit more room. And on the inside, what I'm going to have left is x squared minus x minus 12 equals 0. So I factored out this x on the end because each term has an x, so I can take one from each term. Now this is a trinomial just like this trinomial here. So I'm going to split my second and third terms. I'm going to list the factors. 1 and 12, 2 and 6, 3 and 4. This minus sign here tells me that I should be subtracting these factors. This top set gives me negative 11. The middle set gives me negative 4. The bottom one gives me negative 1. And that's the one that matches. I have a negative 1x here. This equals negative 1. So now my factors are x. Did you forget that first x that we had? Hopefully not. I have this first x. Then I have x plus 3, x minus 4 equals 0. So we have a function equal to 0, we factored out a GCF, we have factored completely, and now our last step is to set all of these equal to 0. We need to set all of those equal to 0. So we have x equals 0, x plus 3 equals 0, x minus 4 equals 0. Well, this one is done. We just have x equals 0. So one of our solutions, or one of our zeros, is 0. To solve this middle one, we do subtract 3 from both sides. So x is equal to -3. And for this last one, we add 4 to both sides, and we get x is equal to 4. Remember, at the beginning, I told you this is an x cubed, so that means when we get done, we're going to have 3 boxes down here with solutions. And that's exactly what we have. Okay, number 3. I'm actually going to put number 3 in my notebook. So I'm going to make a note for myself. And the reason that I'm putting this in my notebook is because it takes these problems, you can see from this one, take a lot of room to do. So I want to be able to have the space to do it and not worry about running out of room. So this is from page 46. This is number 3. So this function is not equal to 0. I'm going to copy it down as it is in our notebook. We need this left-hand side to equal 0, not 18x squared. So how do we make this equal to 0? Well, the only way to do that is to subtract 18x squared. We need to subtract 18x squared, because 18x squared and -18x squared goes to 0. And on this side, we subtract 18x squared. Okay, well, we need to be careful because when we rewrite this, we need all of these exponents to go in order. So the first one we should write down is 3x cubed, then minus 18x squared, finally plus 27x equals 0. And now the first step is done. Our function equals 0. So on this one, we had to move this positive 18 to the other side by subtracting. Now our next step is to factor out a GCF. So it looks like I can take a 3 out of every term and an x out of every term. So I'm going to divide each term by 3x. How did I know that? Because I always check the first number and the last number, or the last letter. So if there's a number on the front, you can usually factor it out. And if there's a letter on the end, you can usually factor it out. So now we have 3x multiply. 3 divided by 3 goes away. That's what we wanted. X cubed divided by x goes to x squared. -18 divided by 3 is a -6. X squared, take away 1x, is just x. And then last, positive 27 divided by 3 is positive 9. X take away X is 0, and that's what we wanted. We wanted to get that X off of the end. Now this all equals 0. So now according to our note sheet, we set it equal to 0. We factored out a GCF. Now we got to factor it completely. So I list all of my factors of 9. I have 1 and 9, 3 and 3. This positive sign tells me that I should be adding these. So that gives me a 10 on the top factors and a 6 on the bottom factors. But that doesn't match. I have a positive 6, but I need a negative 6, which means that I need to change the signs. Change the signs. So now my factors are 3x. Did you forget about that guy in the beginning? Times x minus 3 times x minus 3. That all equals 0. Set each factor equal to 0 and solve. Okay, well, 3x equals 0. X minus 3 equals 0. X minus 3 equals 0. This is 3 times x. So to undo that, we divide by 3 on both sides. And our first solution is x equals 0. 0 divided by 3 is 0. My next one, to solve for x, we add 3 to both sides. That gives me x is 3. And on this one, we also add 3 to both sides, and I get another x is 3. And that's okay, because remember, in the beginning, we had a cubed, and that tells us that we should have 3 boxes at the end with answers in them. And we do. We have a 0, a 3, and a 3. On your quiz, how you would select this, or what your options might be, is simply x equals 0 and x equals 3. Usually, if you have duplicates, you don't put it more than once. So lots of the time, you'll have an exponent like x to the 6th, and 3 of them will be zeros. You don't put the 0 3 times. Usually, you would just put the 0 once. So here, we just put the 3 once. But I want you to see and notice that even though there's only 2 solutions here, there are really 3 zeros because this is a cubed. It's just that one of the zeros was a duplicate. There's really 3 zeros, but one's a duplicate. Okay. We're back in our notebook now on number 4. So number 4 is similar to number 1. We have to set this equal to 0. So we're going to get rid of that f of x, and we're going to say equals 0. Well, this is a special binomial. I'm going to have two solutions, but I know that this guy is special because he only has two terms. Sorry guys, I ran out of space and had to adjust. What I was saying was, in all of our problems so far, in all of our equations, we had a trinomial. So we had three terms on this one, and the one that I put in my notebook. This is the first one where we have two terms. So I can go back to factoring and remind myself what I'm supposed to do when I have special binomials. And that's this case. I have a plus in between, which means that I take the root of the first term, the root of the second term, and I have to put i's on the end because the plus sign doesn't work unless you put i's on the end. So this goes back to your pink card with your exponents on it. So back to this problem, all we need to do is take the root of the first term and the root of the second term, so x, the root of x squared is x. You always have a plus and a minus. The root of 16 is 4, but then you need to put the i's on the end. Then from here, we set them each equal to 0. And we solve. To solve the first one, we do subtract 4i from both sides. To do the second one, we do add 4i to both sides. And now we have two solutions to match our exponent at the top of 2. X is equal to negative 4i, x is equal to 4i. This number 5, I'm putting in a new number 5. So we're going to cross that one out. But number 6, let's do number 6 first because it's a little bit easier. I'm also going to put number 6 in my notebook. I'm going to put number 6 in my notebook just like I put number 3 in my notebook. So I'm just going to make a note that this is in my notebook. I just used too much room to be able to do it in our workbook. So this is page 46, number 6. And it is 6x to the 5th minus, just kidding, equals 30x cubed. Okay, well, step number 1 is that this needs to equal 0, not 30x cubed. Sorry guys, I had another break there. I'm doing Zoom office hours right now. So I think we left off on how do we make this 30x cubed equal 0? And just like we did on the previous problem in our notebook here, we're going to subtract it. So we're going to do subtract 30x cubed. from both sides. Now these won't combine. I can't do anything with these besides rewrite them as 6x to the 5th minus 30x cubed equals 0. And at this point, we're going to have 5 boxes at the end. We're going to have 5 boxes, sorry guys, at the end. So we got it equaling 0. Now we need to see if we can factor out a GCF. So we probably can pull that 6 out. We can definitely pull the x cubed out. We always check the first and the last term. So 6x cubed is our GCF. Six divided by 6 goes away, and we are left with x squared. You have 5 x's and you take 3 away. That leaves you with x squared. Negative 30 divided by 6 is minus 5. And if you use an x cubed and you take 1 away, or you take an x cubed away, so you have 3 x's, you take 3 x's away, you're just left with 5. Okay, this is where this one gets a little bit tricky. We set each of these equal to 0. So 6x cubed equals 0. X squared minus 5 equals 0. Okay, well, let's focus on our 6x cubed. Well, first we want to get rid of this 6. We're multiplying by 6, so the inverse is divide by 6. And we're going to get x cubed equals 0. Well, this is the same as x times x times x equals 0, which is the same as x equals 0, x equals 0, x equals 0. So there are 3 of your solutions. They're all zeros. So we have 2 more to go, which would make sense because this is a 2. Okay, this one's going to be kind of weird because this is not a special, well, this is a special binomial, but we have one issue. What we're supposed to do when we have a special binomial is we root both terms. This guy is a minus, so we're going to have a plus and a minus with no I. The root of x squared is x. But the root of 5 is not a nice number. If I plug in to my calculator root 5, that is not a perfect square. So what we're going to do is leave it as root 5. Now we can set those equal to 0. On this left-hand one, you just subtract root 5 from both sides. So I get x equals negative root 5. And on this right-hand one, I add root 5 to both sides. So I get x is equal to positive root 5. And that makes up all 5 of my solutions. if this were your quiz, you would probably just see x equals 0, root 5, negative root 5. There are 5 zeros, but you have duplicates here, so you don't have to write them down every time. Don't let this side trip you up. It's exactly what we did here. It's just that our number here wasn't a perfect root, so we just leave the root on it. If it's not a perfect root, you just leave the root on and keep the number. If it is a perfect root, then you move forward with that root. Okay, we have one last question, and he is quite the adventure. So, step number 1 is he needs to equal 0. And because I had you guys write this in, I'm just going to erase this f of x on the front, and on the end, I'm going to put equals 0. Step number 2 is we're supposed to factor out a GCF, but there is not a GCF. There is not a number on the front, and there is no letter on the end. So then our next option is to factor completely. And we should be kind of scratching our heads right now because we know how to factor a trinomial. We've just never factored one that was an x to the 4th. But I think I can figure out what we're supposed to be doing. If you go up here, every time you had an x squared, what went in your first term was the root of that, x and x. Same with all of these. Here you have an x squared. What goes in your first term is the root of that, x and x. So down here, when we factor this, what we're going to get in this first term instead of an x is an x squared. So this works the same. Hang on. Pause. I need to make sure I gave you the right problem. I did. So what works the same is we have to list all of the factors of 16. So I have 1 and 16. I have 2 and 8, 4 and 4. This right here tells me that I am supposed to subtract them. So 1 minus 16, 2 minus 8, 4 minus 4. 1 minus 16 gives me negative 15. That matches exactly, so I have my factors right here. So here is where the difference comes in. Now, when we write our two binomials, instead of having an x here and an x here, you have an x squared. So this x to the 4th becomes these x squareds in your binomials. Then it's the same as before. We do a +1 and a -16. So it's the same as when we usually factor trinomials. Really quick, I just want to show you that this does work. So I'm going to multiply that back out for you really quick. x squared times x squared is x to the 4th. X squared times negative 16 is negative 16x squared. 1 times x squared is plus x squared. 1 times negative 16 is negative 16. X to the 4th, 1 positive, 16 negatives goes to 15 x squared minus 16. And that's what we started with up here. So if you have a trinomial and he starts with an x to the fourth, you break him down into an x squared for your first term. And now we have two special binomials. We have two special binomials, which means for these ones, we have a plus and a minus. And then for this one, we have a plus and a minus. So this one is here, this one is here. Sorry, let me zoom out. So for this first one, you root both terms. You get x in your first term plus minus 1 in your second term, and you must put the I on the end because it is an addition. For this one, you do the same thing. The root of the first term is x and x. You'll have a plus and a minus. The root of 16 is 4. This is a minus, so you don't need the imaginary numbers. So now we set all of these equal to 0. Set all of those equal to 0. So we get x plus 1i equals 0, x minus 1i equals 0, x plus 4 equals 0, x minus 4 equals 0. And then you solve them all. To solve the first one, you subtract 1i from both sides. Second, you add 1i. Third, you subtract 4. Fourth, you add 4. And now you have 4 zeros. You have 4 zeros. You have negative 1i, negative 4, 4. You will get some of these in your quiz. So even though they're kind of crazy, I think you can do them. So at this point, we have gone through how to solve these by factoring, setting each equal to 0, and then finding all of the solutions. Now, I am going to teach you a shortcut. Here's the thing, family. Number 1, this really should just be used to check your answers. You shouldn't use this to solve your equations. You can, but you really shouldn't, because some of these problems you guys can factor on your own. Like number 1 that you see in the background, this is one that you can totally factor without needing this shortcut that I'm about to show you. This one down here, he's a little bit rougher, so I can understand how you would want to use the shortcut on these ones that are a little harder. If you are planning to do any math beyond this class, so you want to take 1030 or 1040 or AP Stats, or you're going to go to Slick and you're going to get in the intro math class, or whatever you're going to do, if you are taking any math class beyond this, you should just use this to check your answers. You need to push yourself to solve it the long way and then just use this to double check. So what is this? Desmos. So I'm going to pull up Desmos and I'm going to go through every problem that we've done together so far. So I'm going to open up a window. I'm going to Desmos.com and I am selecting graphing calculator. Can you go somewhere else, Zoomy-Doo? Over here in my bar to enter things in, I am going to type this, guess you can't see it, fam, sorry. This equation, the one that is equal to 0. So I'm going to type in to Desmos x squared plus 6x plus 5 equals 0. And these two red lines now are your solutions to this problem. X is -5, X is -1. Because what you're really finding is the zeros. Notice this is where you have a 0 at -5 and -1. So we go back to our note sheet. We double check our answer. We have a -5, a -1. Okay, next one we're checking is x cubed minus x squared minus 12x equals 0. Now this tells me my solutions are -3. I wonder why this one won't let me click on them. -3, 0, 4. So I have a line going through -3, 0, 4. So now I'm going to come check my answers. -3, 0, 4. Am I going to keep doing this? Yes, and you should stick with me because things are going to get slightly different in a second. So number 3 is 3x squared plus 27x oops, just kidding. 3x squared minus 18x. Sorry, family. I'm not winning right now. Okay. 3x cubed minus 18x squared plus 27x. Okay, right now all I can see is 0. Where's the rest of my solutions? Did I type that in right? 3x squared, 27x. Okay, what did we get in our notebook? I can't find my notebook. We got 0 and 3, but why don't we have one going through 3? Did I do something wrong? Maybe I should just type it all in again. 3x cubed just kidding. Minus 18x squared plus 27. That's not a plus. Well, actually, we'll see. So now that gives us 0 and 3. So what happens when we set it equal to 0? Why is that getting messed up? Very interesting. What happens if I leave this as 18x squared? Well, honestly, guys, I'm not sure why it's even doing that. So maybe this isn't our best option. Or maybe we just shouldn't put it equal to 0. Maybe we should just take the original graph, because you can see the answers now, 0 and 3. Notice that on our actual solutions, we have 0 and 3. So even though there are 3 roots, the graph only shows 2 because there were repeats. Okay, so it worked for 1 and 2. It did not work for 3 if we set it equal to 0. I know there's probably a reason for that, but I don't know what. So this is a prime example of why I'm saying you should really just use this to check your answers and not rely on it to actually get your answers, because if you would have just used Desmos and said equal to 0, the only solution you would have gotten was 0. Okay, so let's try another one. Number 4 is x squared plus 16 equals 0. Okay, I don't see anything. I'm going to zoom out, I'm going to zoom out, I'm going to zoom out. Well, let's put it back to equals. Was that what it was? Nope, let's take the equals 0 off. So notice how your graph here does not pass through any zeros. Your graph does not pass through any zeros. So when I put the equals 0 on, I don't see any lines telling me what the solution is. And the reason why is because these solutions are imaginary. These solutions are imaginary. Look, they're a negative 4i and a 4i. That's why you're not seeing them on the graph. This is another perfect example of why I'm saying you should use this to check your answers instead of using this to solve the problems. Next one, we get x to the 4th. We're only checking 2 more, so I would encourage you to just hang in there. X to the 4th minus 15 x squared minus 16. And now I got to zoom in. Okay, this time all I can see is 4 and negative 4. So I'm going to take the equals 0 off to see what the graph looks like. And the graph is one of these weird W's. It looks like a W. And he only passes through the 0 at negative 4 and 4. But we had 4 answers. However, 2 of them were imaginary. So we got negative 4 and 4. What we can't see are the imaginary factors of negative 1 and 1. So you're going to have to be really careful on that guy when you go to do this problem in your thingy-doozle. What's your thingy-doozle? Quiz. Okay, last one. Hang in there with me. This is our last one. 6x to the 5th equals 30x to the 3rd. Okay, I'm going to zoom in a little bit. This gives me solutions at, it looks like 2 something, 0, and negative 2 something. So maybe now I could subtract this. Okay, well this tells me I'm at negative 2.2, 0, and positive 2.2. Let's check that with our solutions. We got a 0, really 3 zeros, but a 0, a root 5, and a negative root 5. Well, what was root 5 again? 2.2. Is that what Desmos gives you? Yes. So, that is that, family. You have your tried and true, legitimate way to solve these equations, and that is to go through, set them equal to 0, factor all the things, and solve. Now, for some of you guys, factoring is not your jam. That's a huge struggle for you. So you may want to rely on Desmos. You just need to know that Desmos isn't going to get you to 100%. It's going to get you to like 70%. If you're on, you know this, you feel okay about this, then what you are going to want to use is the do it by hand and then use Desmos to check your answers, especially for the imaginary solution ones. So we have two methods: tried and true, work it out, or check Desmos. This is a tough lesson. You guys can do it. Just take it slow. Use Desmos if you need to. We will do building the equation in the next lesson. We won't do it in this lesson. So we just solved. We had the equation and we solved for the zeros. The next lesson is I give you the zeros and you build or find the equation. Okay. You don't have a quiz right now. Your quiz is both lessons. So wait to do your quiz until we do the next lesson. Wait to start the quiz until you do the next lesson. That's all. Love you, Mooey.